4.31 the infinite GP with first term 1 over 4 and sum 1 over 3 is. Now we know the sum to infinity formula is S is equals to A divided by 1 minus R. So this will be 1 divided by 3 is equals to 1 divided by 4 over 1 minus R. This will become 1 minus R is equals to 3 divided by 4 minus R is equals to minus 1 plus 3 divided by 4, and R will be equals to 3 divided by 4 minus 1 multiplied by minus will be 1 over 4. Now since we know that our A is 1 over 4 and R is 1 over 4, our first term will be 1 over 4. Second term will be A into R, so 0.25 into 0.25 makes it 1 over 16, which will be our second term. 1 over 16 into 1 over 4 is 1 over 64, which will be our third term, and therefore our series will be 4.31a, which is 1 over 4, 1 over 16 and 1 over 64. Moving on to question 4.32. Question 4.32 says that the numbers x8 and y are in GP and the numbers xy minus 8 are in AP. The values of x and y are. The first three terms are in GP, therefore x comma 8 comma y is a GP, and if it is a GP, second term divided by first term is equals to third term divided by second term, and therefore xy is equals to 64. Now if the x, y and minus 8 are in AP, second term minus first term is equals to third term minus second term. These are the two relationships in AP-GP as discussed in class, which will make minus x is equals to minus 8 minus 2y, or x is equals to 2y plus 8. Further, after these two things, we can substitute the second equation into 1. We will have 2y plus 8 into y is equals to 64. Now 2y square plus 8y is equals to 64. Y square plus 4y is equals to 32. And now if we solve it, breaking the midterm, first bringing the minus y square on the left, 32 on the left hand side, y square plus 4y minus 32 is equals to 0. And now breaking the midterm, if we wish to break the midterm, the factors will be 8 and 4. Y square plus 8y minus 4y is equals to minus 32 is equals to 0. Now taking y common, y plus 8, taking minus 4 common, y plus 8 is equals to 0. Y minus 4 and y plus 8 is equals to 0. And after that y minus 4 will be equals to 0, or y plus 8 is equals to 0. Therefore the two values of y will be y minus 4 is equals to 0, y is equals to 4, or y minus 8 is equals to 0 and y is equals to 8. Finding the corresponding values of y plus 8 is equals to 0, y minus 8 is y is equals to minus 8. Finding the corresponding values of x is equals to 2y plus 8. If y is minus 8, x will be 2 into minus 8 plus 8, and therefore x will be minus 8. On the other hand, if y is equals to 4, x is equals to 2y plus 8, and x is equals to 2 into 4 plus 8, which is 16. This is when y is equals to 4. Our answer over here is 16 is the value of x and 4 is the value of y. So our answer will be A. Okay, moving on to next question, which is 4.33. 4.33 says that how many terms are there in the sequence, and we are given with a sequence 1 over 128 comma 1 over 64 and so on. To find the value of r, we divide second term by first term, so 1 over 64 divided by 1 over 28. This will give us 1 divided by 64 divided by 1 over 128, which is 2. And to find the number of terms, we can use the formula. We know our first term or our a is 1 over 28. Using the formula of Tn is equals to ar power n minus 1. 64 is equals to 1 over 128 into r power n minus 1. Now if we find the number of terms, we have, what we will do is 64 into 128. 64 into 128 is 8192 is equals to 2 power n over 2. 8192 into 2 is 16384. 16384 is equals to 2 power n. Now if we apply logs, n will be equals to 14. If we apply logs, which was discussed previously, n will be 14. So the number of terms are 14. 4.34. 4.34 says that an auditorium has 20 seats in the front row. Let's say that the front row is the first row, and in the first row we have 20 seats. 25 in the second, so this is term 1. Term 1 has 20 seats, term 2 has 25 seats, and third row has 30 seats. You can see there is a difference of 5, therefore it is an arithmetic progression with d is equals to 5, and so on for 13 rows. Number of seats in the 13th row. So we have to find T13, which will be equals to A plus n minus 1 or 13 minus 1 D. 13 minus 1 is 12. 12 into 5 is 60, and 60 plus 20 is 80. Therefore our answer to 4.34 is 80. 4.35 says the sum of the series to infinity. A is 1, r is 1 over 3 or second term divided by first term, which gives us 1 over 3 as well. Sum to infinity is a divided by 1 minus r. 1 minus 1 over 3 is 2 over 3. 1 divided by answer gives us 1.5, and 1.5 is also equals to 3 over 2. So our answer for 4.35 is D. Last question. Last question of chapter 4 says that the sum of the infinite series, and we are given the first term as 2. Our r will be second term divided by first term, which will be under root 2 divided by 2, and the sum to infinity will be a divided by 1 minus r. Solving the entire equation on calculator, we get sum as somewhere between 6.828 in terms of decimals. However, if we solve it in terms of whole numbers, it will be 2 divided by 2 minus under root of 2 over 2. When divide converts into multiply, this will be equals to 4 divided by 2 minus under root of 2. And if we multiply, if we want it in a single number, we can multiply both sides by 2 minus root 2. divided multiplied by 2 minus root 2 will make it 4 2 minus root 2 divided by 2 minus root 2 whole square. 2 minus whole root 2 square will be 4 minus 2 into, okay, we can instead of doing this, we can multiply this by 2 plus root 2 and divided by 2 plus root 2. So applying the property of a square minus b square is equals to a minus b into a plus b, we will have in numerator 4 into 2 plus root 2, and in denominator a square is 4 minus b square is root 2 square, which will be 2. So this will be 4 into 2 is 8 plus 4 root 2 divided by 2, simplified 4 plus 2 root 2. Therefore our answer will be D. Now you do not need to do all this in your exam papers. I will suggest that in exams you will calculate this on your calculators, and in calculate each value on your calculator as well. One that matches your answer will be the correct answer. Thank you.